Am I audible? Am I audible? Okay, thank you. So in our previous class, we have discussed about very basic things about characterizations of the soil. So I think all of you have already gone through that notes. So if you have any problems or any confusion regarding all the previous notes, please feel free to inform me about all these things. Now, in this class, basically, we'll discuss about some of the very important tests to characterize the soil particles. Okay. Now, what are these tests? So, basically, if you categorize this test, there are different types of tests. So, first one is shear test, then severe test is there, and then some basic properties of the soil, that index properties of the soil, that tests are also there. So I think index properties of the soil that are already discussed in your lab classes. So that would be very much easy for you to go through all these things. So for the shear test, that is very important because but for the soil particles, shear strength is a very important parameter. Now for the shear test, there are three type of shear test: direct shear test, vein shear test, and triaxial shear test. So for our classes or for our transportation engineering subject or pavement material subject, these two important tests are direct shear test and triaxial test. Okay, so direct shear test is basically performed on the cohesionless soil, and in most of the other cases, triaxial shear test is preferred. And from the triaxial shear test, basically for the pavement analysis or pavement material characterization, that dynamic triaxial test is mostly used. From the dynamic triaxial test, we will get to know about the MR value or resilient modulus value, which we have already discussed in our previous class. Now, from the direct shear test, what we will get? So, in the direct shear test, the soil sample is put within a rectangular mold sandwiched between two porous layers. So I'll show you this experimental setup in the YouTube in this class only. So basically from the shear test, we will find out what is the failure load. What is the failure load for various values of normal loads. Normal loads is that loads which would be perpendicular to that axis. Okay. Now by the shear column equation, all of you, I think, know this formula where S equal to shear strength equal to C plus sigma tan phi, whether C is the cohesion, sigma is the normal stress, and phi is the angle of internal friction. Okay, that cohesion for the sandy particles, that cohesion would be 0. Okay, so basically this is the Moore column formula. So this formula for the shear strength is very much important to understand different parameters. Now the friction which is developed because of the interlocking of the particles here also, for as I already told you, for the sandy type of particles, this type of test can be conducted. So the friction which is developed because of the interlocking of particles is contributed by the larger soil particles. So if the soil particles are larger, in that case your angle of friction, that is phi, would be higher. So for the sandy type of particles, if their particle size is higher, in that case phi would be larger. But for the sandy type of particles, here cohesion would be 0, so C it would be 0. So their mean shear strength would be from the internal friction of the particular soil. Now for the saturated clay, the angle of internal friction can be assumed to be 0. Okay, for the saturated clay, it is assumed that the clay particles are very less and there would be no friction in between the particles. So therefore, that angle of internal friction is considered as 0 for the saturated clay particles. Now let me show you the Triaxial test. So see this assembly. So basically, in the direct shear test, what happens? You will put your soil sample over here, and normal stress, that is the perpendicular stress or perpendicular load, will be applied over this place. Okay, there will be different weighing things like this plate. Okay, and each weighing plate or each plate would be assigned with some weight, and you will gradually increase the weight until the soil fails. Okay, so basically this assembly is your direct shear test. This is also available in our lab classes also. I don't know whether you have performed this test or not. See here, three dial gauges are attached. Okay, so basically this dial gauge, it will be taking the note of the displacement, that is vertical displacement, and this dial gauge will be taking consideration of the displacement which will caused by the shear stress, and this dial gauge is basically for the loading condition to check how much load is applied through that plate. Now see how that mold is prepared for the direct shear test. Now the thing is why that graduated line should be perpendicular to that action of the load, so that shear stress can be provided over there. Now, let us discuss about this mold. Basically, that soil sample is in this mold, and this mold can be halved from the mid portion. So, whenever shear will be applied over there, in that case, one plate would be moved in this direction, and another plate would be moving on that direction, which will enable the failure of the soil sample. Now I'm directly going for the test. So this is the assembly. See, these are the different type of loads which you will apply over there. And you will gradually increase the load. See, this is the reading for shear displacement. So basically, this is our direct test apparatus and direct test procedure. So from the direct test, basically we'll get to know about the shear strength of the soil, and from that, using that calculations, we'll understand different parameters of the soil sample. So basically this equation is basically your Coulomb's law, and there are different upgrade versions of this formula, like S dash equal to C dash plus sigma dash plus 10 phi dash. So that formula was given by Moore after that, and that formula is called basically Moore-Coulomb's theory. So you just go through all these portions. That portions are very basic in your soil mechanics chapter. So that thing is well covered over there. Okay, so that is the direct shear test. I think that test is somewhat clear to you. So basically in this test, whatever shear is there, that would be applied directly over the soil sample. That's why it is called direct shear test. Now another very important test is triaxial test. So basically the name triaxial is because here load would be applied from each and every side of the sample. Okay, from x-axis, from y-axis and z-axis. So basically from every angle or every direction, that load would be provided on the soil sample. Therefore it is called triaxial test. So in the triaxial test, what happens, there would be a cylindrical specimen. Okay, and this cylindrical specimen would be submerged into water. So from the water, there will be some pressure over that specimen. Now this pressure is basically called pore water pressure, and from the above you will put some normal stresses. So that is your vertical stress. So that vertical pressure sigma 1 is basically major principal stress, which we have already discussed, is applied from the top, and the uniformly distributed pressure sigma 3 is from the fluid pressure. So how it is applied? So basically whatever soil sample is there, cylindrical sample, that would be submerged into water. So there will be some pressure from the water. So basically from that pressure, whatever pressure or stress is implied over the soil sample, that is your sigma 3 or minor principal stress. Now the term that is sigma 1 minus sigma 3, that is the difference between the major principal stress and minor principal stress, is called deviatoric stress or deviatoric pressure, and sigma 3 is called confining pressure. So in the triaxial testing, various values of deviatoric stresses corresponding to sigma 3 values for the failure of the sample due to shear are noted. So basically there would be, you will note different sigma 3 values for the failure of the sample due to shear. Now this envelope, that is failure envelope, is then used to calculate the C and phi value. So from the shear triaxial test, basically whatever value you will get, that value will be used to find out C and phi values for your this formula, that is S equal to C plus sigma tan phi. So you will get to know about what is the sigma value and what is the phi value from the triaxial test. Now, depending on the various drainage and consolidation conditions, different sets of results may be obtained from the triaxial test. So basically, the tank where the soil sample is submerged, that condition, you can put that condition like your undrained condition and drained condition. So in the undrained condition, what will happen, whatever water is there, that water would be still present over there. There would be no undrained condition, there would be no drainage of the water. But in that draining condition, what will happen, you will continuously supply the water in that tank, and there would be continuous drainage of the water over there. So these are the two types of things. And another very important test, which is very important for our pavement materials, that is dynamic triaxial test. So basically that test is very much complicated, and in maximum of the colleges and universities, that test assembly is not present. That is a very huge instrument. Now in the dynamic triaxial test, what happens? The deviatric stress, that is basically sigma 1 minus sigma 3, that deviatric stress is made pulsating. Pulsating means that would be applied rhythmically. That is, for some instant of time, that load would be there. After some time, that load would not be there. Then again, that load would be applied. Then again, that load would not be applied. So like that, loading and unloading condition. So this test is used to determine the resilient modulus, as we have already discussed. Now, if the confining pressure, so in the triaxial test, if there is no confining pressure, then it is called unconfined compressive strength. And UCS, that is unconfined strength, is generally used to estimate the strength of the cementitious or cemented materials. Okay, so let us go for the triaxial test. That instrument is also there in our lab, but I think that needs some servicing. Just a minute, I'm showing you that. Okay, so basically this is the triaxial test, and this is the sampler where you put your sample and that would be filled with water. So basically in our lab, whatever triaxial is there, that load cell is not there to measure all the applied axial load and deformation. So basically that is a very hyper machine. So whatever we have, that is like a manual thing. So we need to measure that load and the displacement by the dial gauges. So that is basically that enabled the undrained and drained condition of the triaxial testing setup. So basically that is axial loading piston. So from that axial loading piston, if you provide any load, that is basically your sigma 1. Okay, that stress is basically your measure principal stress, that is sigma 1. Now that cell is filled with water, so because of that water, some pressure would be applied in that direction. Okay, some load would be applied in that direction, and from this direction also, that is surrounding that soil specimen. So basically that is your confining pressure or sigma 3, and your deviatric stress is basically your axial loading minus your sigma 3. So that portion we have already discussed. So unconfined compression test is conducted in the triaxial testing. So in that case, there will be no pore water pressure, or your sigma 3 will be 0. So that is your normal stress and that is your shear stress. So basically this is the triaxial test. Now to find out your C and phi values from the triaxial test, basically you get to know about the Mohr circle. So this thing is really covered in your soil mechanics chapters. So please go through that. So then it will be very much easy for you to understand the triaxial test and how you can plot all the sigma and tau values to find out C and phi values. So that is your triaxial test. You just go through all these things. This basically whatever is written there, that is for your exam purpose only, to write something about the triaxial test. Now another important test is there, that is called plate load test. So basically this plate load test is in situ test, and from the plate load test we get to know about the modulus of substrate reaction, or that modulus of substrate reaction is equivalent to your spin constant for the foundation, like that. Now this modulus of substrate reaction is defined as the pressure sustained per unit deformation of the substrate at specified deformation or pressure level with specified plate size used in the plate load test. So basically this is your plate load test assembly. So what happens, that is basically your soil portion where you need to find out what is the settlement over there. Okay, so you just borrow a pit over there and place differences plate over that soil sample. So basically these are the different sizes of the plates. Okay, over that another plate would be there and one loading frame is there. So basically that is your loading frame, and that is the plunger. So you will put two dial gauges or several dial gauges around that plate to measure the settlement whenever load is applied. Now how load is applied? That load is applied in a form of some reaction frame. So some reaction frame would be attached over that loading frame, where you put some sandbags or other things so that gradual load would be applied over there. So in the plate load test, initially a load of 0 point or pressure of 0.07 kg per centimeter square is applied, then it is released. Okay, so basically that 0.07 kg per centimeter square, that pressure is basically called setting load. So why it is called setting load? Because that load is applied so that all this test assembly can be settled properly. Now then a load of 1 kg per centimeter square is applied without any impact, and after that, so initially 0.07 kg per centimeter square load is applied, then it is released, and after that a load of 1 kg per centimeter square is applied without any impact. Now how you measure that load? You measure that load using the probing ring. So whenever that probing ring tells you that your pressure is 0.07 kg per centimeter square, at that time you have to unload it, and again you have to put another 1 kg per centimeter square load over there. Now a settlement rating is taken when there is no appreciable settlement, or when the rate of settlement is less than 0.02 millimeter per minute. So whenever you apply that 1 kg per centimeter square load, in that case there would be some settlement in the sample. But at the time of the settlement, whenever settlement is going on, in that case you don't have to take the reading. You have to take the reading when that settle, that portion has already settled. That is where when there is no visible settlement, or the rate of settlement is very low, which is 0.02 millimeter per minute. Again an additional load is applied and the corresponding settlement is loaded. Again after that some additional load is applied and corresponding settlement is loaded, like our severe test. Now, generally, there are a number of dial gauges put in different direction to find the average value of the settlement. So here, basically, the diameter of the plate would be like 300 millimeter or 700 millimeter. So basically, that is a rounded plate. So therefore, you need several dial gauges to measure the settlement throughout that entire area. So after that, whatever settlement reading you will find out from that, all that dial gauges reading, you just average it and find out what is the total average settlement for that plate. So for the plate load test, loading may be continued up to a settlement of 25 millimeter. Okay, so up to 25 millimeter, you have to apply the load. So for the severe test, you have to apply the load up to 12.5 mm penetration or 12.5 mm displacement. So similarly, for the plate load test also, you have to apply the load until there is total of 25 millimeter of the penetration or settlement. So the modulus of substrate reaction is defined as K is equal to P by 1.25, where 1.25 is basically the displacement. So a standard plate size of 750 mm diameter is generally recommended for the plate load test. And if a different size of plate is used, in that case, K value can be calculated using this formula, that is K1 into D1, where K is the modulus of substrate reaction, D1 is the plate size, equal to K2 into D2. Okay, so using that formula, you can find out what is the plate load test or modulus of substrate reaction for the different sizes of the plate. So the plate load test can be individually performed on base, subbase or subgrade. One test per kilometer is recommended for the assessment of the K value, and performing a plate load test is costlier than the severe test because there is huge assemble which is required in situ. Now the severe value of the soil is used to predict the K value only if the plate load test data is not available. So if you don't have that plate load test value, in that case you can predict the plate load test value using the severe test. So generally the severe value is used for designing the bituminous pavement, and your K value or modulus of subgrade reaction value is for the concrete pavement. So it is however matter of convention only, and IRC 58/1988 provides the following relationship between severe and K values. There are some relationship between severe and K values. So basically these are the relationship. So when your severe value is 2%, in that case that K value is around 2.08. So like that, based on the different severe values, you will get to know about different K values or modulus of subgrade reaction values. So if your severe value is in between some points, suppose if your severe value is 7, in that case you can go for the interpolation and find out what is the K value. So this is the basic table to find out your K values corresponding to different severe values. See, this is your platelet load test assembly. So basically that is the loading frame, and loading is applied over there using some sandbags. So you see the loading frame. Now, this is the plunger through which your load would be applied. So generally for the test, rounded shape of plate is used. So but in this case they are using that rectangular size of the plate. In that case, the calculation, some of the calculation would be different. This is to check whether that is in a perfectly horizontal position or not. After that, see that loading frame would be placed over that center line. I think these tests are somewhat clear to you. So the notes for the class, I have already shared this in your group. So you just go through all these notes, and the next class, we'll discuss about the severe test. Basically, you know about all this severe test. So I'll discuss very basic portion of the severe test, and after that we'll go for some numerical examples based on the severe test and plate load test.